Okay. So the last session of my presentation will be I will present a data portfolio just to start giving people an idea of what I've been talking about data portfolio. And throughout, I've been discussing on the different steps on how to analyze data, what some questions to answer, because it's all about, as I said, it's all about answering business questions and making decisions out of the data. So I'll just give you a brief overview of one or two data projects I've worked on, what we're trying to answer, and provide some visualizations that answered some of the questions and provided us insights of what's happening in the data for the decision makers to make informed decisions. So that said, yes, so welcome back. So we'll move straight to the presentation, which is data portfolio. So the first project which I'll be presenting today will be what I call quality of life after the PICU. So what is PICU? PICU, and this is very important in the data analytics in the whole in the mindset of a data analyst, right? The first thing you need to understand the data, which is extremely important. You need to understand every column in the data. So most often when you get data from, let's say, a client or from your company, so if the data was provided to you by the data engineer, or even if you want to retrieve data from the database, most often you need to know what the columns mean. The columns are the features, right? So as I said, things like the name, the address, the age, that's what we call the columns, or what we call the features. So you need to understand all of these features. So sometimes the company has what we call metadata, which is data about the data. And in the metadata, they have what they call a data dictionary. Again, I'll add all of this in the glossary, so a data dictionary. So let me just put that. So a data dictionary will explain to you what each of the columns in the data means or what it represents. So it's very important to understand. So you have a lot of interactions with your clients or with domain experts. In my case, it was with clinicians and doctors. So we had a lot of interaction to understand what this PICU data represents. And PICU, as I said, is Pediatric Intensive Care Unit. Pediatric intensive care unit is the care unit for children who are very ill. So imagine children at less than 18 years old who are very ill, going through having certain issues. It may be cardiovascular, it may be heart issues, lung issues. When they are very ill, they go to the PICU and they undergo through different treatments in the PICU. So they may give them oxygen, they may give them steroids, they may give them different treatments in the PICU to help them recover from their illness. So the data here, we were trying to analyze the quality of life, or what we call the health outcome of children in the first year after they are discharged from the PICU. So as I said, they are admitted to the PICU, they go through a lot of treatment. Then after that treatment, they are discharged from the PICU. Then we want to understand the trajectory of their quality of life, or of their recovery. So how they recover throughout the first 12 months after they are discharged from the PICU. So there are certain, just doing that, you already know for us, as I said, you can already imagine that this will be like a time series data. So we're going to have data of the child in each month, his health outcome, his quality of life, what we call quality of life, or his health outcome. We will know his health outcome maybe 1 month after he was discharged, 2 months after, 3 months, 4 months. So it's a time series data. And with time series, the first thing you always want to look is what we call the longitudinal analysis, which is just a time series analysis. You want to just see the trend of how children are recovering over time. So we want to see that trend. So that was one of the questions we wanted to know. We wanted to know which months did the children recover generally. So for all the children, did they actually, was it an upward trend? Because that's what we expect, right? So the first thing to note is when they leave this PICU, they are very ill because they have gone through a lot of treatment. So we want to see, do they recover? Do they start getting back their quality of life after they leave the PICU? So we want to look this longitudinal study and want to look the proportional analysis. Proportional analysis is simply we want to look at the proportion in each month, the proportion of children that recovered back to their baseline. Obviously, before they were sent to the PICU, we kept track of their health. So we know that this child was a very happy child before he went to the PICU. After he left the PICU, we want to see the proportion of the children in each month that are going back to their happy life, or the proportion that are going back and seeing, just measuring the proportion. You can imagine the importance of this to the clinicians and the health and the doctors. With this, they can be able to know that, okay, maybe they have noticed that within the first month, a lot of children are very unhappy. Most of them have not recovered. Then they will be able to create different interventions within the PICU to help in this improvement of children's health outcome over time. So these are certain decisions or certain insights we want to get from the data. These insights obviously were provided to us by the clinicians, the doctors who provided us this data. As I said, sometimes they provide this and you have interactions with them to make this problem or the solution or the problem you want to solve, to make it clearer, because sometimes they don't actually know what they want, but you need to have this interaction with them, interaction with the data as well. So you'll be looking at the data, you'll be asking them questions, and they'll be like, okay, yeah, this is what we want. Also, we wanted to do machine learning analysis. So obviously we have historical data of how each of the children recovered back, how their health outcome after 12 months. And we also have data of what activities or what treatments took place when they were in the PICU. Then we want to create a machine learning algorithm that will predict for every new child that comes to the PICU and undergoes a certain amount of treatment. We'll be able to predict that this child in the next 12 months will either not recover to his quality of life, or will become healthy, or will stay ill after 12 months. Remember, we have data for it, and that's what we will use to train the machine learning to be able to predict new children that come to the PICU. So we use all children that have come to the PICU. We use their data to train a machine learning, and when new children come to the PICU, we'll be able to predict that if a child takes a cardiovascular support, or if it injects steroids or whatever, there is a high probability for them to recover back to their quality of life, or there is a low probability. So that is the machine learning analysis which we had to do as well. So that said, I'll just show you some visualizations which we use and some of the results from this analysis which we are trying to answer these different research questions. So the first is, the data set. So it'll be good to first start with the data, right? So this is the data. This is a sample. Obviously, it's not the real data, because the real data is private, right? It's health data is very sensitive. So I just created this data myself. So again, if you look at this data, the first thing you can know is it's an aggregated data. So each row represents a patient. Each row represents a patient. So we have patient 1, 2, 3, 4, 5. Then these dots, I'm just saying they can be 1 million patients. And for each column, these are what we have been mentioned, the features or the columns. And these are the characteristics of that patient. So features and columns always are characteristics or measurements describing the entity. In our case, the entity is the patient. So the patient has an ID. This patient 1 has an ID. His age is 8 years old. His gender is a male. He weighs 30 kg. His height is 130. He's Caucasian. And these are as I mentioned, this is the data of the treatment. So if you look at it, this is treatment during PICU. So these are the treatment the child went through when he was admitted in the PICU. So these are the different treatments that the child went through. Obviously, there can be more. I just created this as well. So he went through some mechanical ventilation. So 1 represents he went through that ventilation. 0 represents he did not go through that treatment. So 1 means he had that mechanical ventilation. Antibiotic therapy he didn't go through. Oxygen therapy he didn't go through. Broncho bronchodilation bronchodilator therapy he went through it, and steroid administrator he went through it, and so on and so forth. So we have that information about all the patients that were admitted during the PICU. We have their information. So each observation represents an information about each patient, which is an aggregated data, as we said before. The second data set is the quality of life after the PICU. So this is the data during the PICU. So after the child now is discharged from the PICU, we also collect data. So now you see that the data here is what we call a time series data. So for each patient, so remember, let's say that patient 1 is this patient 1, who are the age, the gender, and so on. For this patient 1, he has information at different time points. So time point -1 in this case, I'm just saying 1 month before he was admitted in the PICU. Time point 0 is the month at which, the day at which he was discharged. So this is 0 means discharge from the PICU. -1 means 1 month before he was admitted to the PICU. So this is what we call the baseline, his baseline quality of life. So before he was admitted to the PICU, this child was had a high functioning. So this on 100. So it was very functional, 90% functioning status. His quality of life was 95%. His physical activity was high. He was very physical, moving, happy child. His quality of sleep was very good. But when he was discharged, which is 0 month, you see that everything reduced, obviously because he was ill. He had gone through a lot of treatment in the PICU. So this reduced significantly. 1 month after we have recorded his information, 3 months after he was discharged, we have recorded his information, 6 months after we have recorded his information, and 1 year after we have recorded his information. So you can already see that for this child. So that's why we say for Python or data analysis is meant for big data. So imagine someone gives you data only for 2 patients. Imagine this ... means we can have 1,000 patients. If someone gives you data only for these 2 patients, you don't even need Python, right? With only your physical eye, you can know that you can look at this quality of life and know that this child did not recover back to his quality of life. Or you can look at his physical state and say this child did not recover back to his physical activity, and so on and so forth. For this as well, you can just look at these 2 columns and say this child. So there's a lot you can do just looking at the data when the data is small. With an Excel sheet, you can analyze it there, but imagine now you have 2,000 children. You need to summarize all of this information. You can't do that again with your naked eyes, and that's why you need an automated tool like Python to analyze this large amount of data. So this is time series data after their discharge, and this is the treatment data before their during their PICU. So for the longitudinal analysis, obviously we are using the time series data. So we're trying to analyze the children, and we're trying to analyze how this is a distribution. So we are going to learn that this is what we call a box plot. A box plot just shows you the distribution of the entire population for over time. So for the baseline, the green line shows you the median, or what we call the mean, right? So this is the mean, so the average quality of life of all the children in the baseline. Baseline is 1 month before they were admitted. So the average was about 870, you would say. So the average, or 75, the average quality of life for all the children in the database at the baseline period was around 75. Then when they were discharged, you see this drop of the average. So this box plot just shows you this is the minimum. This is the first quartile. We're going to learn all of this. Don't be overwhelmed. This is the first quartile. This is the median. This is the third quartile, and this is the maximum. So there were children that had a quality of life of 100 during the baseline. And there were children in the baseline that had this, what we call almost like outliers, had a very low quality of life, even at the baseline, had a very low quality of life. So this distribution shows you the entire distribution of the data. So you can actually start making informed decisions. So you can already imagine that a decision maker, the data was like this, you cannot make any information about it. But when you summarize the data using visualizations, you start seeing things clearer. So now a decision maker can easily know that, A, there were children that really had low quality of life, and the average number of children, the average quality of life was about 70. And there were quite a large amount of children that had good quality of life and up to about 100. And they can know this distribution. So the trend, if you focus on this median, you see that the trend goes down during PIDs, during discharge, and starts going up during first month, third month, 6th month, and 12th month, which is good. So when we showed this to the decision makers, they were like, wow, that's what they expect, right? They want people to get back to their normal life, their normal quality of life. So you start seeing this trend upwards. Then hypothesis now can come into play. So a basic hypothesis will be, is there a statistical difference between this increase? So 12 months shows an increase, right? But is it statistically significant? If there is no statistical significance in the increase, therefore the children change, their health between 12 months and 6 months is the same. It's statistically the same, even though we can see an increase. So most often the visualizations summarize things, but sometimes you don't want to make conclusions from the visualizations. You now want to draw hypotheses. And that's where you start saying, okay, is there actually a statistical significance between the average health outcome we are seeing in this 6 months and what we are seeing in the 12 months? And that's where you bring now statistical tests, and the statistical test will tell you that even though you see an increase, this increase is not significant, it's insignificant. Therefore, you will be like, okay, it means 12 months and 6 months don't actually have a significant difference. So if it was sales, right? So your sales department will come and show you this and say, hey, wow, we sold more products in 12 months. But now the decision maker will be like, let's look for the statistical significance. And they'll check the sales here and the sales here, and the decision makers will discover that there is no statistical difference in this, even though there is a difference in the distribution, but statistically there is no difference. Then the decision maker will like, the sales department, what the sales you made in during the 6 months is not different from what you did in the 12 months. So you need to make more effort. So the visualizations are good. Then from the visualizations, we create hypotheses from the visualizations. And you can see now that different analysis have been done. So we in the data, we filtered the data. So if you look at this data, patient 1, we know the age of this patient 1, which was 8 years old. We filtered the patients by children that were under 2 years and under, to analyze their behavior, and we filtered the children that were over 2 years. So children over 2 years. And why did we do that? Because the domain expert told us that children, you can imagine a child who is 2 years old, right? His activity level is quite different from a child who is 2 years and above. And so 2 years and below, the activity level, a baby does not play around. It's just a baby eating, drinking milk, but 2 years and above, there's a lot of activity. So you cannot bring the analysis together. You bring in noise, and you're providing, that's where we're saying integrity. So you need to be able to have these interactions with the domain expert. I never thought about it. Obviously, I know it, but I never thought about it. But an interaction with the clinicians, that's the first thing they thought about. They're like, no, we can't join the analysis for 2 years and all the children, because 2 years and above, their activity level and what they go through is totally different from children that are above 2 years. Someone can even say above 5 years is different, and you do more granular analysis, right? So you have 2 years, 2 to 5 years, you have 5 years and above, you have 10 years. Puberty, someone will say the children in puberty, children above 10 years are different, and that's when it becomes more interesting, right? So you have all of these different stages of analysis. So what we did as well is this was the health outcome for children in the UK. We now went to our research and looked for the average health quality of life of children in the US, and we just added that information in our plot, right? So we know that children in the UK, their baseline in terms of health were lower than children in the US, and critically ill children in the US, we also just added more information. So you can add different levels of information to your plot to make more decisions or provide more information to your stakeholders. So this was just a simple comparison of what we are having with what children in research of others who have done this research in the US, and how we compare with them as well. Again, proportional analysis. For each time point, we're looking at the proportion of children that have recovered back to their baseline, which is the green. So this tells us that 33% of children in the when after they were discharged were already above their baseline, already had good quality of life. And you can see that a large proportion, 37% of them, were 30% below their normal quality of life, while you have the other percentages. So you have 30 to 20, you have 20, you have 10, but this is the one we are really interested in. So about 37% had more than below 30% of their normal quality of life. So we're trying to analyze the proportion. So you see that these two plots are totally different. This tells you the trajectory, while this now tells you the severity. This now tells you the proportion. So different visualizations give different information. Obviously, with time, you're going to learn which one to do. And with interacting with the domain experts, they're going to also give you ideas of which one to do. In order to plot this graph, the analysis you do on the data will be totally different from the analysis you do on the data to plot this graph. Obviously, different graphs have you write different code to plot different graphs, which obviously you will learn with time depending on the problem you're trying to solve. So don't worry about, is it complex to write the proportion graph, or what we call stacked plots. So for people who know plots, this is what we call a stacked plot. Is it complex to write a stack plot? Yes, it can be complex. Is it possible? Yes, it's possible. Is it complex to write a box plot? No, it's not complex. Is it possible? Yes, it can be possible. So there are more complex plots you will need to write in order to solve different problems. So that said, we go to the machine learning analysis. So obviously we are not teaching machine learning now, so you don't need to understand what I'm saying now, but I'm just trying to intrigue you now about things you should be aware of when we're talking about visualizations, when we're talking about statistical analysis, when we're talking about creating research questions, communicating with stakeholders, and obviously machine learning. In machine learning, as I said, we use historical data of an event. So our event is people have been admitted into the PICU and they have been discharged and they have lived for 1 year, and we know that some of them, we know the if they recovered back to their baseline after 1 year, and we know if they didn't. So we have historical data of the entire picture. We take that historical data and we train a machine learning that will use that historical data to find the pattern between what happens in the PICU and the child recovering back to their baseline. The machine learning will train that algorithm. If it discovers a pattern, is what to measure if the machine learning has discovered a pattern, we look for the performance of that machine learning. So the performance will always be things like the accuracy, the mean, the absolute, the error of the machine learning. If the accuracy of the machine learning is high, then the assumption is the machine learning has discovered the pattern that can map things that occur in the PICU with the quality of life, which is the target, what we call the outcome. It has because it has a good performance. Obviously, the performance will be taking the historical data, their true quality of life, we'll take the machine learning and we'll predict their quality of life, and we'll compare their true quality of life, because the machine learning does not know their true quality of life, right? So we'll take the true quality of life, we'll take the predicted quality of life, and we'll compare them. If the scores are close together, then we know that the machine learning understands how to use the PICU, the treatments in the PICU, to predict the quality of life. Then we will measure the performance of the machine learning, and you always, when you're doing machine, you always hear about performance. So you hear if the machine learning is accurate, if it's of high performance, if it's of low performance. Obviously, if the machine learning is of low performance, you don't want to use the model, right? You want to use models that are of high importance. That means you can rely on the model. That means the model has captured the patterns that to predict the quality of life. So you always see things like the performance of the models. Obviously, you don't need to know this now. We will learn this when we get to the machine learning analysis. You always hear things like the predicted values of the machine learning model, which is the predicted values which the machine learning models have predicted. You hear the actual or the true values, which is the real world values. So for those children, we know their quality of lives, and we will predict their quality of life. So those are the true and the predicted. And you will hear what is becoming very common now. Before it was not very common, but what we call feature importance. Feature importance in machine learning is simply understanding which of the features. When we talk feature, we're talking about the input data, right? Which is in our case, the measurements during the PICU. So the mechanical ventilation, the age, the antibiotic therapy, all of these. These are the inputs to the model. So we want to know which of these factors are most important for a child recovering back to their quality of life. So we will do things that we call feature importance. So now you don't just want to predict, but you want to know which factors are driving the prediction. In our case, I'm just giving an example. These are just coefficients. So this is just telling you that the mechanical ventilation is most important during the PICU when the child is in the PICU. The steroid administration is second in importance. The child's weight is important. So if you give the child more ventilation, for example, the child may not recover back to their baseline. So this is just giving you some rules for you to be able to get an intervention. So when you know this, what the doctor will do is the doctor now will go and say, hey, we have discovered that giving children more ventilation affects them to recover back to their baseline. Therefore, we need a way to give them less ventilation, but still give them some other treatment that will ensure that they recover back to their baseline. So this just gives the decision makers more information about the predictions, so that they can drive decisions, so they can know where to change their decisions and how to update their decisions, and so on and so forth. As I said, you don't need to know all of this now, because it's just to intrigue you of what we were talking about machine learning, what you should expect. You should expect a model performance, you should expect feature importance, which features are driving the predictions. You should just expect these things. That said, we will go to the next use case. So if you have any questions about this use case or this data portfolio, please send your questions to the chat. Send your questions to the chat. But to conclude on that, this is exactly what you would do when you're creating what I call the data portfolio. So when you open a PowerPoint document. In an interview, the interviewer will always ask you to present your projects or your data or a portfolio of your projects which you have done before, and this is what you would do. Similar to what I've described, is the same thing you would do. You start by describing what the data was you were analyzing, what the aim was for that project, what you had to analyze quality of life, which were the methods you used to analyze that data. So you put down the methods you use, the machine learning or whatever analysis you did to that data. You give a brief introduction about the data to your presenter. So you give a screenshot. If the data is sensitive, you can create a dummy version of the data similar to what I have done. This is no data. I just created this. You create a dummy data to represent the data you're talking about so that the presenter understands what the problem you're trying to solve. So you create this dummy data set. You will now present the results of your analysis as visualizations or as performance, machine learning performance, and so on and so forth. So you present your longitudinal analysis, you present your proportional analysis, and you present your machine learning analysis. You present the results similar to what I have done. And what happens after that is the presenter, the interviewer will start asking you questions with regards to the project. So you ask you which machine learning model you used. In this case, I've not told you about any machine learning model. He'll ask you why. So you always have to know how to answer the why question. There are many machine learning models out there. For every machine learning model you use, you must have a reason why you picked that machine learning model. So the interviewer will ask you why you use that machine learning model. He will ask you how many features you had in your database. Were there any issues you faced? Do you think if you had more features, would you have used the same machine learning model in these trends? What do you think about these trends? Do you think the color plotting in these trends are okay? Do you think, how did you create these trends? Why did you create these trends? What question were you trying to answer while creating this trend? They will ask you. Every question of the interview will be based on your portfolio, what you have done. That is why I said it is extremely important you learn the skills, because you will be assessed based on the skills, what you have done before. So I advise everyone after this presentation that you just create a PowerPoint document and you start creating your own portfolio with the data sets, which I'm going to show soon. So this is the first project. The second project, I'll quickly go through this one because I've taken a lot of time in the first project. The second project is all about fuel consumption. So I've moved from health, now I've gone to transportation, or what we call civil engineering. So imagine a road, right? A road was created, and 1 year after they maintained the road, so they put in a new layer of tar in the road to enhance the road and to improve the road, right? So the road has deteriorated over time, and now they have improved, they have maintained the road, make sure the roughness is good, the texture is good, they've increased the layer of road, and now they have data because cars go through that road. And because there's a certain company whose trucks go through that road, the government has come and seen that company and is like, okay, this company, your trucks go through that road. So, and that company has what we call a telematic system. A telematic system is just simply a sensor. They capture data from the vehicles at each time point when the vehicle is being driven. So you can imagine Tesla, right? Tesla sensors, or a truck. Trucks, or most trucking companies have sensors embedded in their trucks, which capture the speed of the car, the acceleration, the fuel consumption of that truck, where the truck is at every point in time. They use this to manage their fleet of trucks. So the government comes and meets this company and like, oh, I know you have a fleet of trucks and you have more than 50% of the trucks in the UK, and now your trucks have gone through that road which we want to see. We want to test a hypothesis. We want to see that the road maintenance we made on that road is either improving fuel consumption or reducing fuel consumption. We want to just test this hypothesis. And the trucking company is like, okay, I'll give you data of all my trucks that have gone through that road before they went through that road and after so I'll give you time frames, right? From the year that they went through that road before the road was maintained and after the road was maintained. And so we want to analyze what we call the fuel consumption. So it's basically looking at the fuel consumption before the road was maintained and the fuel consumption after the road was maintained to see if there's a difference in fuel consumption. So these are basic questions which companies may want to answer. In our case, the company wanted to answer that question. And so we're trying to analyze the differences in fuel consumption. The analysis, again, we're trying to do we'll do a lot of data transformation because the data just came to us in a very raw format. When I mean raw, it means there are a lot of things The speed, the distance the car traveled was not in the data. The data just gave us the longitude and the latitude of the car. But strange enough, you can calculate the distance of a car, the speed and everything from just the longitude and the latitude. So the fleet company does not calculate speed. They just capture the locations of their truck. But if you look at the location of a truck now and 1 minute after, you can use that location to calculate the distance the truck has traveled and the speed and whatever the truck and so on and so forth. So we have to do a lot of data transformation. And that is where you have been hearing the term data transformation. That is what data transformation is. The data you will receive may never be in the form at which you can analyze because it's in a very raw format. You may have to create new features, generate new features from using the existing features in the data to create new features which are more analyzable or which you can analyze easily. So this is what you'll be hearing data transformation. Data transformation is always just transforming that raw data to a more to a data which can be easily analyzed. So we did a lot of data transformation. Again, we did trend analysis because you will see it's temporal data again. We did some clustering. Clustering is just looking at patterns in the data to see if there are some like patterns in the data. So I'll quickly go through that. And obviously, yeah. So again, it's temporal data, it's time series data. This is not aggregated data. So if you can look at it, each vehicle has a duration, a time at which these are the time in this day, the 1st of January 2023. These are the different times. During this time, data was captured by the truck. So the latitude and the longitude, that's the location of the truck, the fuel consumption at that time, and the vehicle weight. You can see the vehicle weight changes over time because this vehicle is moving and delivering items to different locations. So sometimes the vehicle would deliver items and the weight will become lower. Sometimes it will pick up items, the weight will come higher. And all of this is measured by the sensors in the truck. So the sensors in the truck capture the weight of the truck. So we have this for 2 trucks. And again, can have many trucks. So this is just giving you, as I said, the first thing is always to present the data. So when I present the data, you start understanding what questions you can ask, what is in the data. You cannot learn data analysis without data. You need data to start playing around with. So that's why I try to present first the data, so you start having an idea of how real world data is. This is real world data from a truck or a vehicle. Obviously, it's sample data which I've created as well. So the first step in that our analysis was data transformation. The first criteria, which was a criteria we had when we were interacting with the domain experts, is we want to consider trucks that have more than 2 rows in the data. Why do we want 2 rows? Why we need 2 rows is so if in the data set a truck has only 1 row of data, remember it's a time series data, it always has 1 row of data. In our case, this truck has 5 rows of data. If it only has 1 row of data, it's impossible to calculate the distance, because to calculate the distance, I need to use 1 location and a second location. I need 2 locations to calculate the distance, right, between the truck. And if I don't calculate that distance, I'll not be able to calculate the speed of the truck. I'll not be able to calculate the fuel consumption, because we need to normalize the fuel consumption by the distance. So these are certain things you have interaction with. So this is what we call data cleaning. During the data cleaning process, you are moving things that will not help your analysis. So in our case, we're trying to remove vehicles that have more than 2 rows or more than 1 row. So yes, only keep vehicles that have more than 1 row and remove vehicles that have 1 row. Then we had to transform. So we had to use an algorithm to transform the latitude and longitude to a distance. Obviously, you don't need to know that algorithm now. If you look at online, there are many. If you Google how to use the location of 2 points to calculate the distance, they will provide you. And that's what I did when I was doing this analysis. I never knew it offhand. I went to Google and it provided me a function, and I coded that function in Python to calculate the distance. After we calculate the distance, we now want to transform our data to aggregated data. So for each vehicle, we want to get its total distance, its total time, its total fuel consumption, and so on and so forth. So those are technical things. So sometimes we transform, as I told you earlier, we can transform time series to aggregated to ease your analysis, because in our case, we don't want the time series, right? We want the aggregated data for each vehicle to know if the total fuel consumption of each vehicle or the average fuel consumption of each vehicle increases or decreases when after the maintenance of the road. So this is the aggregated data now. So we have done all of this. We have removed the vehicles. We have aggregated the data. We have calculated the speed now, which is the total distance which we calculated divided by the total time which we have aggregated. And we have normalized the data. Sometimes you need to do these things. Normalizing the data just means if a vehicle travels 1,000 kilometers, its fuel consumption will be more than a vehicle that travels 2 kilometers. So you cannot say that vehicle has consumed more. So we normalize to make sure things are comparable between elements. So we normalize by the distance. So we look at the total consumption, the total fuel that has been consumed by the vehicle. We look at the total distance that vehicle has covered. We divide the total fuel by the total distance to get a normalized version of the fuel. So we know that this fuel consumption is comparable with even someone who just drove maybe 2 kilometers or 4 kilometers. So these are some of the things you'll be doing when you are doing what we call the transforming of the data, the cleaning of the data. And all of this knowledge, obviously, as I said, is when you are interacting with the domain experts. We're having this interaction, they'll be like, no, we cannot use total fuel consumption. We need to use a normalized fuel consumption, which is the fuel consumption divided by the distance, and so on and so forth. So this is the aggregated data which has been transformed from this time series data. And so now it's totally different from this time series. In this time series, we had latitude, longitude, fuel consumption. Now we don't have latitude, longitude again. We just have average weight, we have speed, and so on and so forth. So the data, we have transformed the data totally to a way that we can now analyze the data. And for analysis, using the date column, because for each vehicle, we still have its date when it traveled and its aggregated values. So using the date column, so you see that this is an aggregated time series data. So it even becomes interesting again. So even though it's aggregated per vehicle, it still has time, which shows that there's still a trend. So you can still look at the time over each of the vehicles. So these were just the trend analysis. We're looking at how the fuel consumption, the red is the segment of the road that had the control where the treatment was done, and the green is another segment just before this segment where no treatment was performed. So we're in statistical analysis, we will always have that control group, which obviously I will still describe in statistical analysis, because the control is to know whether the trial is the behavior in the trial is good or is statistically significant and so on. Don't bother about those terms now. But from the control, you see that 2017 is before the treatment occurred. 2019 is after the treatment occurred. So if you even look at the control, you see that it's almost the same. You have this fluctuation in fuel consumption. But if you look at the trial segment, 2017 is the segment before it occurred and after. So you see this gap between 2017 and 2019. Therefore, the fuel actually reduced significantly when that road was treated. So we have this trend analysis. We have other forms of analysis. So as I said, don't bother about all of these visualizations. We'll go deep into it. I'm just presenting what we call a data portfolio. So we have other visualizations to tell other stories. So this is per month. So we're looking, instead of looking at the trend over the year, we're now looking at per month. We're looking at between the control and the trial, which obviously you don't need to worry about this. Clustering as well, we're trying to see if there is a relationship between the weight of the vehicle and the fuel consumption. And if you can see, we are seeing some clusters. Clusters are just groups of values. So we're seeing some interesting clusters. So you can actually see that low weight cars which are of less weight, or heavy cars, heavy vehicles have consume more than small vehicles. So if you have a small vehicle, you are in a good place. If someone has a G-Wagon or something, he may be consuming more fuel. So more heavyweight consumes more than smaller vehicles. So these are just doing clustering. Obviously, you will learn more about clustering when you get to the machine learning, because this is machine learning. When you get to the machine learning and part of the machine, and you learn what a cluster is and what this is. But this is just providing more information. So that said, we have 15 minutes, so I'll try to be as quick as possible. So that is the data portfolio. So we have two projects, one relating to health, one relating to civil engineering or transportation, and we have to present insights. You have to know the questions you want to answer. You have to transform the data to suit the analysis which you have to perform. So when you receive data, you don't just start analyzing the data. You have to ask questions. You have to understand the data, and you have to most often you have to transform that data to the way to a format at which you want to answer your research question, because you have research. In our case, it was fuel consumption, and in order for us to answer fuel consumption, we needed to calculate the distance, because we needed to normalize the fuel consumption by the distance, and so on and so forth. So you need to know these different stages of regarding your data. For each data, this task will be different. So you don't have to cram this task, but you have to just be aware of the kind of things that you need to ask your data. You need to ask your data, is all the data valid? Do you have to filter the data by certain conditions? Do you have to clean the data? Do you have to create new features which make more sense? And so on and so forth. So that said, I'll be presenting the available data sets. As I said, from the get-go, we need to start creating our data portfolios. And these are the data sets I have in this course. So we have more than sorry, I didn't put the count of the data set, but I would say we have more than 13 data sets here in different domains. So I would put all of this data in, because this is public data. You don't need to public real world data. There's no privacy with the data. So I'll put all of this in our Teams channel, and I will call on all our learners to pick 3 data sets from this list of data sets. If you don't have, as I said, some people already have the data sets which they have. Some people run companies, they have the data. Some people are doing research, they already have the research data. If you don't have data, go to the folder, the data set folder, which I'll create after this. Pick 3 data sets and start understanding them. You don't have to start analyzing them, because we have not started reaching the analysis. Just start reading. I'll provide data dictionaries for the data set. So for each data set, I will explain to you what the columns mean. So you start reading the columns, understanding the columns, importing the data to your Visual Studio, because already a lot of us already have the Visual Studio. Just check how to import this data to your Visual Studio. Import the data and just start looking at the data, or open the data even as an Excel sheet or a CSV file. Look at the data and start thinking. I want to get thoughts for each of your data. Start thinking, what can I do with this data? What insights can I want to know in this data? What research questions may I want to answer? What hypotheses can be developed from this data? What machine learning, what predictive analytics can I want to perform? Do I want to predict in traffic? Do I want to predict the traffic at a particular time of a day? Do I want to predict housing prices in a certain country? Do I want to predict the stress level depending on your health metrics? They want to predict if someone will pay their loans or not. If someone with a certain criteria, if I give that person a loan, would that person pay me on time? Using historical data of other people who have taken loans. Do I want to predict the grade of students? So if a child has this particular demographics and this particular characteristics, would the child be able to graduate on time or not? Do I want to see which employees, if an employee is in my company, the probability of that employee leaving my company, which is what I call employee churn? Would that employee leave my company, or what's the probability of that employee staying in my company? And so on. You have ride hailing. Do I want to know the amount of rides that are covered in a certain region in my app? If I have a ride-hailing app, if I have a crash or an incident app, do I want to know the factors that are driving people to have road accidents. Road accidents are quite high now in the US and in Cameroon. So do I want to analyze this data and know what are the factors driving road accidents or and so on and so forth? So we have all these data sets. Again, if you have a very if your domain is very specific and you feel that you can't see any data here, any data set here that will suit your interest, please leave a comment in the chat and just tell me your domain, and I'll do my work to look for data related to your domain that will be interesting, because the whole learning process will be very, if you use data of your interest, I think you will learn faster. You get the interest to learn, you get the anxiety and so on and so forth. So if you have an interest in a specific domain and you believe the domain is not listed here, or you don't have the data that will suit your interest, please leave me a comment in the chat with the domain that you want, and I will look for the data that will suit that interest, so that we are all in the same page, everyone is happy, everyone understands and builds a data portfolio. So in your PowerPoint document, you should have 3 sections for each of your data sets. As I said, everyone should take 3 data sets and start building your data portfolio. And obviously, I'll conclude by how to maximize my training. So there will be pre-learning preparations, which I said I will send activities after each learning. For example, we have our next lecture will be SQL. So we'll start with SQL in our next lecture. So I'll send pre-learning, I'll send activities on how to install SQL. I'll send some learning on learning about SQL commands and how to write SQL code. I would encourage to maximize this training. You always have to try to go through all the pre-lesson preparations, familiarize yourselves with concepts, install the necessary software, use Copilot as much as possible to speed up your learning. Secondly, I want people to ask questions. For the past 2 lessons, I've been happy. People have asked questions, who have made jokes of things, which is what we want. We want to be engaged in these group discussions, Q&A, and I want people to send me feedback on how I'm performing, if I'm too fast, if I'm too slow, just tell me how I'm performing so I can improve my lectures. Select data sets. Please select 2 to 3 data sets of interest so that you can practice everything you are learning in this training, and you can use your own data sets. As I said, some people come with their own data sets. Use your data sets to practice the skills and to create your data portfolio. We'll have sessions where we'll go to the data portfolio starts from now. So we'll have sessions where people will present their data portfolio and what they have done. We'll ask questions, we'll be interactive. I'll present some more projects which I have done. These were just 2 projects I've done. A lot of projects. I'll present other projects which I've done to pique people's interest and for people to ask questions. Practice, practice, practice. Yes, we need to practice all the things we are learning in the course. We need to go out there and practice things that have not been learned in the course. I wouldn't be able to teach you everything. So go out there, search for other things which I may have left out, practice things, complete all assignments on time, and I believe by the end of the 11 weeks, by the end of August, we will all be experts and specialists in data analytics and with the mindset of a data analyst. So that's all for my presentation, and that's all for the lectures for today. I don't know if we have any questions, so I'll just go quickly through the chat to see if there are any questions. If anyone has any questions, please feel free to put your questions now so that we can answer them. Okay, I see we have some Q&A. I like the Q&A part of it. So did the aggregated data for the PICU case come with a metadata dictionary that explain what 01? Exactly. So sometimes the 01 is even part of the transformation. So sometimes it may come with numbers. They may tell you the features may be numerical, and when you're having discussions with the stakeholders, you may decide that you want to transform those numerical values to binary, to a 0 or 1. So at sometimes it may come as 0 or 1, and the dictionary will tell you that 0 means the intervention or the treatment was not performed, And 1 means it is good if I go to the data while explaining that answer. Yeah. So 1 means the treatment was performed, while 0 means the treatment was not performed. In some cases, mechanical ventilation will have numbers. It may have 90, 0 to a percentage, and the experimental may say anything below 50, let's say it's a 0. So you have to do that transformation during your pre-processing when you are cleaning the data. So you will say for every value of mechanical ventilation that is less than 50, let's replace that value with a 0. Otherwise, we replace the value with a 1. So sometimes these things will be done by the analyst. Sometimes it will come already in the data. But I want to prepare your mindset that most often the data comes in a very raw format, which you need to clean up, transform data, play around with the data to get it to a format at which you want to analyze. Most often the data will not come and everything will be as clean as you see, because now this is just a hypothetical data I'm giving you, and it's already clean and shows you it's already processed. Sometimes the high, the very low, the moderate, the very good will be numbers, and the interaction with your domain experts will be like, okay, let's transform this to categories. So instead, if anything is between 0 and 1, let's say it's low. If anything is between, so there will be this form of transformation. That's what you see, what we call data transformation. There'll be different levels of transformation, different levels of cleaning up the data, and different levels of modeling the data as well. So any more questions? Okay, let me see. I had some. Okay. Are we going to have data cleaning practice? Yes, Janet, we're going to go through the entire data pipeline hands-on. So I'll be showing my screen. I'll be presenting how I clean the data, how I transform the data. I'll give you best principles, best practices on how to clean the data, how to transform the data. This will all be live hands-on sessions with me. So we're going to go through the cleaning practice. We're going to go through the transformation practice. We're going to ask the questions together. So don't worry anything about that now. Just get to understand the concept. So were we able to join our okay, get the record. Yes, after this, the recordings will be put in the Teams. So there's a Teams channel, there's a folder where we will put all the recordings. If I just quickly share, I know just 2 minutes left. So if I quickly share my screen to show, is it the calendar? So yeah, so can everyone see my screen? So we have a Teams channel. This Teams channel is where we will put all the recordings. So for example, today we have had it's our first lecture. Under the general, sorry, there is a files under the general. And I'll update in the WhatsApp group when I've put in information. I'll update everyone. So now we have the lessons 1 introduction. Under this, we will have all the recordings for the videos we have had today, or there's anything we have done or any assignment which is supposed to be done will be put under the lecture. So for next week, I will start putting in code. I'll start putting in exercises to do before the lectures. I'll put in these different folders. And obviously, I'll encourage everyone to go through the data analytics glossary to know more about terminologies. I've been using a lot of terminologies with the assumption that some of you know. I apologize because I'm really familiar with it, but always go to the data analytics glossary. And if you don't understand any concept or any term that I say, please leave me a message and tell me you don't understand what does this term mean, so that I add that into the data analytics glossary for everyone as well. Yep. Let me go back to the chat and see. I think there's a question. When you're explaining box plot, you mentioned something about statistical signal where the fact that a value was high didn't mean that it was statistical. I didn't get that. Yes, a very good question, Vanessa. So sometimes statistical significance does not mean that it's not different. It means the difference is not much. That's what we call significance. So even though something was higher than something, it means that difference is not very much. It's not significant, right? So that's what statistical significance means. It doesn't mean they are not different. It means they are still different, but that difference is not significant. It can be due to chance. What the statisticians would say, they can say that difference, maybe that day was just a sunny day and the marketers went out and it was more sunny, and during one day they sold more. But it doesn't mean if that day, it doesn't mean normally they sold more. It was just due to chance, due to an external influence, and so it wasn't significant. As a maker, you always want your decisions to be significant, or the insights you get to be significant. So if the sales in this month was more than the sales in this, you want that difference to be significant, to be much, right? So that's what we mean by statistical significance. It doesn't mean the sales were no more. So the trend will say we sold more, but this increase was not very significant. Therefore, we need to do more to make it significant. So that's what statistical significance means. But as you said, high is higher than low, but high may not be significantly higher than low. So that's the whole idea about significance as well. And I don't know if I answer your question, Van. And let me see, another question has come in. Will there be office hours? Where is the Teams folder? Please also share links on email. I had from WhatsApp. Are you going? Yes. So everything, there will be office hours. So I'll reiterate that now in the WhatsApp group. We have drop-in sessions. I'll send the timetable. We have drop-in sessions where I will be in teams for everyone to come in with questions, come in with solutions, come in with things to interact. It starts from this week because some people did not come in on time. So the first session will be 5:30 p.m. British summer time. I'll send the whole information on the WhatsApp group. So don't bother about that. I'll be on Teams. I'll send you a Teams link for that session, a drop-in session, what we call office hours. You can come in with any questions you have, and we'll be able to answer that during those hours. We have those hours again during the week on Wednesdays and Fridays at different times. I'll send you the timetable, and remember, it's British summertime. So during those hours, I'll send the links to everyone. You can click on the link, join me. Sometimes I'll just be there doing my programming and just having fun. Maybe this session, I'll be there to show people how to install SQL. If anyone has had issues with installing Visual Studio on Mac, you can come into the session and maybe show a screenshot. Just having fun and maybe playing some music at the background and coding, having a coding session. I know we haven't had any technical classes today. So this session, the drop-in sessions this week will mostly be home assignments to be done. So that said, thank you, everyone. I will not take your time because I intend to keep the times very strict, so that because we have other drop-in sessions, we have different channels to ask your questions. Please put in your questions to the channels. I'll send the links to the channels again for everyone to put in your questions. Sending your questions on WhatsApp on the channels. I will send general information on WhatsApp because everyone has the WhatsApp installed in their phone. And if you have any issues, please use the channels to ask your questions. Avoid sending me private questions so that everyone can learn from the answers I provide to you, because others may be facing the same problem. And let's enjoy ourselves, and welcome once more to this training. I hope we all will have fun. I'm already having fun, and I thank you so much for your patience, and I look forward to having you next week again. Thank you, and have a nice weekend and wonderful weekend. Bye-bye.